Let's get our feet wet with an angled projectile. In other words, a projectile that is launched at an angle. So in this case, they are telling us that a puma is jumping at 45 degrees to the horizontal, jumps to the height of 3.7 meters, meaning that the highest point that the puma can reach is 3.7 meters. That is a vertical displacement. And remember, in order to successfully solve a projectiles problem, we need to be able to separate our x and y from each other. So in the horizontal direction, I do have v0 cosine of 45, which happens to be the same as the vertical component, which is vy initial, I'm going to say, equals v0 sine of 45. So in other words, if I remember that sine of 45 and cosine of 45 are equal to each other, and they are indeed root of 2 over 2, that's what you remember when you memorize unit circle, which is also the same as 1 over root of 2. So Vx in my case is the same as Vy, and it's just initial speed over root of 2 for vertical and horizontal. The only difference is the vertical is going to change to a 0, right? V0 over root of 2. I have the formula V final squared equals V initial squared plus 2g change in y. I know that g is negative 9.8. If change in y is positive, then g has to be negative 9.8. So v final at the top is 0. My v initial squared is technically 0 minus negative 19.6 times change in y. Then my v initial is just root of 19.6 times 3.7, 8.52 meters per second. That's my v initial vertical, mind you, right? So v0 over root of 2 equals 8.52, from where v initial is just going to be 852 roots of 2, 12 meters per second. That is the answer to this lovely problem about a puma. You're welcome.